Chapter 3, section dealing with derivatives. Okay, I need to prove to you, first of all, this will be on the quiz on Friday, so make sure you know how to prove this particular theorem. I'm on page 191. Okay, and this is theorem 3.3.2. Okay, in this theorem it says, if f of x is equal to x to the n, I'm going to prove that f prime of x is equal to n times x to the n minus 1. Alright, first of all, we're going to start out with limit definition. Okay, f prime of x is equal to limit. Okay, let's say h goes to 0, f of x plus h minus f of x, all that over h. Okay, so this is the function we're working with. So this is now same thing as a limit as h goes to 0, and this now becomes x plus h to the nth minus x to the n, all that over h. Okay, I have to expand this using a binomial expansion, binomial theorem, limit as h goes to 0, and that would be x to the n, okay, plus. Okay, then I'm going to have x to the n, x to the n minus 1, and then h is to the first power. And my factorial in front of that is n factorial, all that over n minus 1 factorial times 1 factorial plus. I am expanding this right now. Plus, I'm going to have x is to the n minus 2 power and h is to the second power, and my coefficient in front of this will be n factorial over n minus 2 factorial times 2 factorial plus. And then I'm going to have x to the n minus 3, and then h is to the 3, and this will be n factorial over n minus 3 factorial times 3 factorial plus dot 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 dot, and I want to see those dots. Okay, and then it's going to be some random term, which is going to be x to the n minus r, and then h is to the r. This would be n factorial over n minus r factorial times r factorial, and then plus dot 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 dot, plus the last term is h to the n. Okay, and that's just this part right there. And then I have a minus x to the n, which is that part right there, and all that's going to be over h. Now, this is positive x to the n, this is negative x to the n, so they're going to cancel out. And then every term that is left, means that term, okay, this term, and everything in the middle, and that term, and the last term will all have h in them. And then when I factor out an h and cancel with the bottom h, then this will now look like limit as h goes to 0. This term, okay, will not have h because I factored out and canceled out with the h. So that one will have n factorial over n minus 1 factorial times 1 factorial, and then x to the n minus 1. Okay, and then plus. This one, this term now, I factored out an h and canceled off, so that'll be n factorial over n minus 2 factorial times 2 factorial, and that'll be x to the n minus 1. Since I factored out one of the h's, that'll be h to the first. And then plus dot dot dot, and then this will be 1 less h, so it'll be n factorial over n minus r factorial times r factorial. It'll be x to the n minus r, and that'll be h to the n minus, or r minus 1. Excuse me. R factored one of the h's out. It would be r minus 1. And then dot 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 dot, and then the last term here, there'll be one less, will be h to the n minus 1. Now when I take a limit, that means when I plug in 0 for h, this will turn into 0. Everything in the middle will turn into 0 because they will all have h's in them. And then this will turn into 0. Okay? And then this will turn into 0. And everything in the dot 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 will turn into 0. So the only thing that I have left out of this whole thing is n factorial over n minus 1 factorial n times 1 factorial x to the n minus 1. Now if I clean this up a little bit, I have n times n minus 1 factorial, all that over n minus 1 factorial. And of course 1 factorial is just 1, and then have x to the n minus 1. Now the n factorial, n minus 1 factorial, is going to cancel with that n minus 1 factorial. That'll give me n times x to the n minus 1. And there it is. So what does this mean? Okay, so here it is. So if you have f of x is equal to, let's say, x to the third, okay, all you have to do is to find the derivative. You don't have to do it the long way anymore. You're going to take 3 and multiply by the coefficient, which is 3, and subtract 1 from the power, which is 2. It's done. So if your f of x happens to be 10x to the third, then f prime of x is going to be 10 times 3, which is 30x to the second. And if you have f of x is equal to, let's say, 5x to the 100, you don't have to do it the long way. If you did, you'll be here all day long. So this means f prime of x will be 500, okay, x to the 99th power. And that's the derivative of that. Of course, this works for polynomials also. So they have rules over here for polynomials. So if you have a polynomial like, let's say, f of x is equal to 5x to the third plus 3x to the second plus 4x plus 10. Okay, remember, this is a constant. So it has a power, it has x to the power of 0. So remember that. You don't have to write that. But I'm going to write that just for right now so I can show you what happens to that. So when I take the derivative of this, I can take the derivative of each one. That's going to give me 15x to the second. When I take the derivative of that, I'm going to get it plus 6x to the first. And then I'm taking 1 away from the power each time. When I take the derivative of that, it'd be 1 times 4, which is 4, and x to the 0 power, okay, which is really 1. And then when I take 0 and multiply by 10, that turns into 0. So that's why a derivative of a constant is 0. So if you clean this up, this is 15x to the second plus 6x plus 4. Okay, power goes down by 1. Okay, let's do a couple more of these polynomials real quick. Okay, let's say my f of x is equal to, okay, negative 10x to the fifth plus 4x to the third minus 3x plus 100. Okay, so if you take the derivative of this, I'm going to take 5 multiplied by negative 10, which would be negative 50x to the fourth. I'm going to take 3 multiplied by 4, which is 12, and now x to the second, because I have to take 1 away from the power. And then the derivative of that is just going to be negative 3, and derivative of a constant is 0, so that's going to go away. And this is the derivative of that function. Now we also have a product rule and quotient rule. And there are proofs of these, okay? I will spare you the proof, okay? And then I will just state what they are. Okay, I'm on page 193. We have a power rule, okay? Power rule says this, okay? If you want to take, and this is another symbol for a derivative. So far I showed you that you could use, okay, f prime of x, that's the derivative. That's same thing as y prime, or same thing as a y prime of x, and also same thing as derivative of function y with respect to x. You can write it any way you want. And sometimes they also write it like this, derivative of, okay, f of x, all that over dx. Okay, and another way to write that is still the same thing, okay, dx f of x. That means take the derivative of the function f of x with respect to x. Okay, so there's multiple ways of writing a symbol for a derivative. Okay, so let's take this theorem 3.3.5 on page 193. Okay, so you have a derivative with respect to x of two functions f of x times g of x. This is known as a product rule. Okay, the product rule says if you want to take the derivative of two functions, it's going to be first times the derivative of the second, first times the derivative of the second, plus the second, you'll have to memorize this, times the derivative of the first. Okay, in this particular rule, the order doesn't matter that much, so you're good to go. But the quotient rule, the order does matter. Okay, so here's a quotient rule. When you take the derivative of a quotient function where you have f of x over g of x, now notice the g of x cannot equal to 0 with respect to x. Okay, that will be denominator, which is g of x, times the derivative of the numerator minus the numerator, which is f of x, times the derivative of the denominator. Okay, all that over denominator, denominator, which is g of x, okay, squared. Okay, g of x squared. Okay, I'll do some examples of all of these. And some people like cute little rules, okay, and it's like low, and the derivative of the high means on the top, okay, minus high times the derivative of the low, okay, and then bottom squared. Okay, low d high minus, okay, minus high d low, bottom squared, and off we go. Okay, low d high minus high d low, bottom squared, and off we go. Okay, or this is more formal definition. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all that over denominator squared. Okay, so power rule, quotient rule. Okay, and product rule. Okay, let's take some derivatives and we'll be done with it. Let's go to, I'm on page 198. Okay, problem number 2. Y is equal to negative 3x to the 12th, so y prime is negative 36x to the 11th. Done. Okay, let's take a look at 8. Okay, y is equal to x to the second plus 1 over 5. You'd be tempted to use quotient rule because this is a quotient. Don't do that. Do some algebra first. This is really 1/5 x squared plus 1/5. Think about that. Now when I take the derivative of this, that gives me 2 over 5 x to the first, and of course the derivative of the constant is 0, so that's done. Okay, let's keep on moving. Okay, let's get to number 12. Number 12. Yeah, y is equal to 7x to the negative 6, okay, minus 5 times square root of x. This is really 7x to the negative 6 minus 5 times x to the 1/2 power. So when I take the derivative of this, I'm going to multiply negative 6 times that, which is going to give me negative 42 x to the negative 7, because I got to subtract 1 from the power, minus 1/2 times 5. It's going to be 5 over 2 x to the negative 1/2. Done. Remember, I'm subtracting 1 from the power each time. Okay, so let's hop, skip, and jump, and let's get to problem like number 16. Number 16, okay, you're given f of x is equal to 2 minus x, okay, minus 3x to the third, okay, times 7 plus x to the fifth. Now you can multiply all this out, do the algebra, and then take a derivative. That's too much work. So since this is a times here, okay, we can use a product rule. So derivative of this would be first, which is 2 minus x minus 3x to the third, times the derivative of the second, which is just 5x to the fourth, because the derivative of the 7 is just 0. And then you have a plus second, which is 7 plus x to the fifth. Let me erase that. X to the fifth. And then I take the derivative of the first, okay, then derivative of 2 is 0, derivative of that's going to be negative 1, okay, minus 9x to the second. And that's it. You do not have to simplify that. You can leave it as is. Okay? But if you want to simplify, you can. And if you do simplify, if you make a mistake, I'll take points off. Alright. So, quit while you're ahead. That's the moral of the story. Number 20. Okay, f of x is equal to x to the fifth plus 2x to the second power. In this one, you might want to rewrite this as x to the fifth plus 2x times x to the fifth plus 2x. Okay, then we take the derivative of this, f prime of x. Okay, every time you don't write that, when you take a derivative, okay, I'm going to take a point off also. Okay, first times derivative of the second, so first is x to the fifth. Let me erase that, otherwise you think that's a negative sign. First, x to the fifth plus 2x times derivative of the second, which is 5x to the fourth plus 2, and then plus second, which is x to the fifth plus 2x times derivative of the first, which is 5x to the fourth plus 2. That's done. If you want to simplify, you can. Alright, now let's go ahead and move on down to number 22. Number 22, you're given y is equal to 3, all that over square root of x plus 2. And they want you to find y prime of 1. Okay, so that means they want you to take the derivative of this and then substitute in 1. Okay, we have to use a quotient rule, so y prime, which is denominator, which is rad x plus 2, times derivative of the numerator, which is 0, because derivative of the 3 is 0, minus the numerator, which is 3, times the derivative of the denominator. That's really x to the 1/2, so that's going to give me 1/2 x to the negative 1/2, and then derivative of the 2 is 0. Okay, all that's going to be over, okay, denominator, which is rad x plus 2, quantity squared. Okay, this is going to go away when you multiply by 0, so only thing I have to do is when I plug in 1, I'm going to have a negative 3 times 1/2 to 1 to the negative 1/2, okay, all that over, okay, square root of 1 plus 2 squared. Now I do have to clean this up. That's negative 3. 1 raised to negative 1/2 is still 1. So that's going to get me 1 times 1/2 is 1/2. All that over. In the bottom, 1 plus 2 is 3, so 3 squared. And this is negative 3 over 2 divided by 9. So that simplifies to negative 3 over 18. Okay? And you can leave it there, or you can reduce if you choose to. Okay. Let's move on down to number 24. Okay. This is number 24. You're given x is equal to t squared plus 1, all that over 3t. and they want you to find dx dt. So the function is x, and the independent variable is t. So what you want to do is you can use a quotient rule, but you can also use algebra first. So I'm going to use algebra first. This is going to be t squared over 3t plus 1 over 3t. I'm going to clean this up a little bit. Okay, so the t's are going to reduce, and that's going to give me t over 3. And then I'm going to take this to the top, and that'll be 3t to the negative 1. Okay, now I'm going to clean it up just a little bit more. That's 1/3 t plus 3t to the negative 1. Now I can take a derivative of this, okay, with respect to t. Okay, derivative of this is just 1/3. Okay, and then derivative of this I'm going to use, and I better do a little bit more simplification first. 1/3, otherwise I'll have to use chain rule, and you're going to be confused. 3 to the negative 1, t to the negative 1. Okay, so what is 3 to the negative 1? That's really 1/3. Okay, so that's 1/3. Okay, and when I take the derivative of t to the negative 1, that's going to be negative 1 times t to the negative 2. So if I clean this up, I get 1/3, then minus 1/3 t to the negative 2. And there it is. Okay, alright, let's do one more. Okay, and then we can call it quits. So let's go to 26. So 26. Okay, they give you y is equal to 4x plus 1, all that over x squared minus 5, and they want you to find, okay, dy dx, and they want you to evaluate that when x is equal to 1. Okay, and that's what it means. First take the derivative of this, and then they want you to find, basically they want you to find y prime of 1. Okay, so let's take the derivative of this. You have to use a quotient rule on that one. Y prime. Denominator, okay, that's that high d low, okay, or low d high minus high d low, bottom b squared, and off we go. Alright, so denominator, which is x squared minus 5, times derivative of the numerator, which is 4, and minus, and it's a minus in the middle, minus the numerator, which is 4x plus 1, times derivative of the denominator, which is 2x. All that over denominator squared, which is x squared minus 5 quantity squared. Now you will be tempted to simplify this and then plug in 1, because we're trying to find y prime of 1. Okay, so notice I'm writing this down, y prime of 1. You have to write that down also. But it's easier if you just plug in 1 where it is and then simplify. So when I plug in 1, I'm going to get a 1 squared minus 5, which is 1 minus 5 times 4. And then minus, when I plug in 1, I'm going to get 4 plus 1 times 2 times 1, which is 2. And all that's going to be over 1 squared minus 5, okay, and squared. So if we clean this up, okay, this is negative 4 times 4, which is negative 16. And then this is going to give me 5 times 2, which is 10, so minus 10. All that over negative 4 squared, which is going to give me 16. And on the top, I'm going to get negative 26. On the bottom, I'm going to get 16. And there it is. And y prime of 1 is negative 26 over 16. Okay? Alright. That is it. So let's finish off yesterday's homework and then get started on this for today. That's it.